All right, folks, we have Tony Anderson and Adam Holt talking about Olpc, the maker mindset, and school servers. Thanks.
So Samir introduced at the beginning that one of the components that's required, really one of the elements in a deployment, is some device that's essentially offline from the internet, since many of our deployments are not online. And that's the school server. We call it the school server. It's a server. There's nothing unique other than that. And I think we had in the previous talk a very clear indication that the school server is still important even if you have access to the internet, because much of the information that you might want to download from the internet is already available on the school server. And so that bandwidth to the internet can be, you can avoid using that bandwidth, which could, as we found, could be very expensive and available only for a short time during the month. School server basically serves content. That's its purpose. And so therefore you need to have large storage because you want lots and lots of content on the server. Right now we're at about 500 gigabytes. So we've got half that disk drive available for new content. Here in the building we have an example of Rachel Plus, which makes a school server. This costs $399 with content previously installed. And with a little bit of luck, I can get out of this for a moment and we can take a look at that. I need to get into the browser. Generally speaking, you get the school server through a browser, which essentially means that it's available to any laptop, mobile, any device that has, in fact, a school server. So let me open this in a new tab. Now this is not the Rachel school server. To get to the Rachel school server, there are two things you have to do. One is you have to connect to the Rachel network. And then what you have to do is you have to do http://Rachel for the URL. And there you see the Rachel content. And it's just like you click here to start and you see this, essentially the Rachel that we see on our school server. Khan Academy Lite, Wikipedia, Wikipedia for Schools, World Map. This is actually the same one that's on XSCE 6. Wikivoyage, Sailor Academy textbooks. I don't put this on the school server because I'm not sure that that's free to distribute. C to K-12 textbooks, these are the ones done here in California to save the royalties. TED Talks. This GCF Learn 3 I also don't think is actually free. I think that's proprietary. Radiolab, Phonics, great work. This is one of the important contributions of Rachel. This is actually taking books from the Gutenberg collection and putting them into collections so that you can look for books of a particular topic. When you're dealing with the whole Gutenberg collection, you have to know the author or the title to find anything. Here's the African Storybook Project. I don't know the scale of the universe. The Hesperian Health Guides, Medical Encyclopedia, Practical Action in Various Agriculture, Crop Processing, and so on. Now the way Rachel does it is all of the items that are available in their content you get by scrolling down, and when you find the one you want, you click on it. And it takes you there. Here's Wiktionary, Oregon Youth Authority, Olpc educational packages. Olpc doesn't even know they have these. They're really old. Khan Academy Lite. These are the videos. The other one I think was the actual exercises. And then it goes to Spanish, and as you keep going down, it'll change over to French. So here we're now down to Wikipedia in French. Second one we have back there is XSCE 6.1. And I have to get on the right network for that to work, which in this case, if you look at it, it's the one that's squawking IIAB for Internet in a Box. And you can, okay, this is what we call a portal page. this is the page you get when you open up the browser to the school server. And essentially it's 3 pages at the moment. Class, a collection of things that we'll look at, but basically there's 3 columns of items. If you click on any one, it'll take you to something most of the time. Library, this is where the Wikipedias and that kind of content is. And then the resources, really resource pages. There were too many items on the first page, so I had to create a second page to break them up. So I can't argue that this is the way it works exactly. Okay, let me see if I can get back to the presentation. So we have those models. There's also a Raspberry Pi back there, or actually I think Alex has the one that works. And what are you squawking?
Olpc SF.
Okay, so if you connect to Olpc CSF and you do HTTP school server, you should get to it, right?
Rachel.land.
Okay, that's right. Yours is a Rachel. Okay. But anyway, the point is in the classroom, you have 40 students with 40 laptops, all of them with Wi-Fi. They then can connect by SSID to the school server, and they can independently gain content. Content is local on the school server and its terabyte drive. So there's no need to be connected to the internet. And if you're connected to the internet, but you're going to the school server, you're not going to be using any internet bandwidth to take advantage of it. And Fedora, on Raspberry Pi, you can have it either Fedora-based school server or Raspbian. Okay.
Question.
On the Raspberry Pi, Raspbian is an established distribution, but running Fedora Raspberry Pi, how stable is it? Have you had any experience with it?
I never use Raspberry Pi because it doesn't have enough content storage.
Okay.
I can't get a terabyte.
I was just curious about Fedora's performance.
But
availability on that.
I think Adam can speak to that.
So I'm working on both a lot this week.
Okay.
And yeah, 2 of the guys who did most of the work are sitting right here. They both work, Raspbian and Fedora, which is amazing. It means that potentially we can expand our community dramatically beyond just Fedora and CentOS for the people that are religiously on the other side.
Yeah, just say on what other side?
Oh, the Ubuntu Debian, Raspbian side of things.
In the server space?
Yes.
Well, so my
That's gotta be
question
religious.
specifically was, the reason for my question was that XSCE, the way it is built, its architecture with Ansible and playbooks and all those things, largely came out of the Fedora world.
Right.
But Debian support for low power devices, ARM-based ones, has been historically a lot stronger, right? Because they've been doing that for a while. However, taking the XSCE school server running onto Debian, say on the Raspberry Pi, was always an interesting use case, but challenging, which is why I want.
What's the connection between Debian and low power?
Well, Debian has had ARM support for a very long time, which the Red Hat Fedora and NAS support is not.
Okay, but right now, like the MUC back there, I don't think it draws more than maybe 2 more watts than a Raspberry Pi. The
No,
new.
that's fine. No, but I'm just saying any ARM device that was there in the market, the default choice would be something that was Debian based because that's where the.
Okay, but for servers today, it really doesn't matter a bit because only way Intel can compete is they've got to make theirs lower power than ARM in order to get into the mobile marketplace. And so this is the 6th generation machine, and it's pretty low power. I would imagine maybe 2 watts more. I don't know that anybody's ever measured it, but
So I want Tony to give his presentation. If there's time,
Yeah.
you've asked the most interesting question. If there's time, the 3 of us, George, Jerry, and I can explain that there's been massive progress on the Raspberry Pi. What I like to call the $100 school server, not the $100 laptop, the $100 server. It's very interesting, but let's have Tony go first.
at the bottom line, Adam's objectives and mine are quite distinct. And so anyway, this foil is really just showing you, if you go to Amazon today, what it's going to cost you to put together a school server. There's 2 models of the Nuke. If you use the Celeron version, then you could put together the school server for $128. If you want to go the 6th generation version, you go $278 or well, the total is 384, I think. But the goal of this whole thing is, from my point of view, the server should cost less than 2 times the XO cost. And the XO cost is roughly $200. So if you're under $400, that to me is fine. Because I'm looking at distributions that have at least 15 laptops and more typically 30 to 100. And if you add 2 more, the cost of 2 more, that's pretty negligible in terms of the total project cost. There are other vendors that you can get the school server from, Gigabyte, Zotac, MSI, Shuttle, all make sort of competing models. But we've kind of been using the new because it works and we understand how it works, and that's how that goes. Raspberry Pi, the RPI 3, $35, case probably $10, AC adapter $10, SD card $40, so you're looking at under $100. And you can negotiate lower prices if you look around than these. These are just strictly right off Amazon. So you're looking at $100 versus maybe $300, and you're looking at a fraction of 128 gigabytes available content versus a terabyte, and that's where our priorities kind of differ. Okay, and in here was what's new with the school server. Now I'm talking about the school server content that I put together, as opposed to necessarily the content that's on XSCE. And what I do is I'm building a hard drive called Bernie, for Bernie and Ascenti, but it's actually Basic Educational Resources for Innovative Education, in case you want a mnemonic. Okay, anyway, the point of this is, with this hard drive, a deployment should be able to install all of the software that is necessary to run that deployment. So on here I have all the images for all the different models of the XO. I have custom scripts that convert those, customize those sugar installs to add capabilities like the codecs for MP3 and MP4 and a lot of other things. And it has all of the content that you want to install on a school server. And the idea here is that if you are managing a deployment like in the Dominican Republic, where there might be 20 schools, you could do all of them from one hard drive, because you're only going to be in one place at a time. And you don't have to have any contact with the internet. Now, the devil is always in the details. And putting together a deployment and getting every part of every script right, I haven't quite got there yet. The closest I've come is the last install in Karachi. There were 5 patches I had to make. And those 5 patches, I didn't have to download any new content. That's actually a milestone in some sense. Okay, with this, I've added an application that allows the user to select what content they actually want to load on their school server. The XSCE standard package, if you like, also has that capability, but they do it by a different implementation. Mine is just using bash scripts pretty much, and Django is the interactive part. So the new things that, as far as content is concerned this year, PHET, these are simulations in science and math from the University of Colorado. Toys from Trash, these are how to make things out of everyday items that you have around you to illustrate scientific concepts, done by Arvind Gupta in India. Absolutely marvelous. Kiwix, before we were delivering the content using software coming from Internet in a Box, but now everything except the OpenStreetMaps is being delivered by Kiwix. Much a better, faster, better searchable way to go. And Khan Academy Lite is now like a second generation. It's not just math, there's also all kinds of other subjects included. But the big change for me this year is I'm trying to move from the school server as a static store of content delivered to the school at the beginning of the year to something that the students and faculty can update with local content created from day to day. A part of that is I have a library capability so they can upload books or any kind of media, it doesn't have to be a book, and make it visible and shareable. And secondly, the remote journal. The journals on each of the XOs gets backed up to the school server and can be made available from the school server and can be selectively shared, or the teacher can look at it and so on. And I'm looking for a technique that I think there's software available to support, where we can do this independently of sugar. There's a software called iRods, which is creating a database that consists of a metadata string and the file. And that's exactly what our journal does. So it looks like a matching implementation that we might be able to put together. And this upload capability where a user can create a file on the journal and click on that file and upload it to the school server and share it with others. And of course, we won't have time to illustrate all of that, but oh well. What I want to do really is to talk a little bit about the context. We've heard a lot yesterday and today that's extremely relevant, I think, to what I want to talk about here, in a sense. My model of this, when you look at the school curriculum, particularly in Rwanda, but also in the United States, I call it the Scholastic Olympics, because the school forms a team. And the principal is the manager of the team. And the team is going to field their students as entries in an event, which is taking a proctored test. And so in Rwanda, they take the 6-year leaving exam. And this is proctored tests, just exactly like they do it here at the university, I suppose, for final exams. In Kinyarwanda, English, mathematics, science and elementary technology, and social studies. Obviously, computer technology is not included because only 20% of the schools have laptops in Rwanda. Literally, in the École St. Jacobs, the school I work with most closely, there are 52 schools in that district. And each school gets a printout from the government at the end of the year, ranking that school from 1 to 52 on the results of their participation in this test. So last year, École St. Jacobs, I think, was 5th out of 52. And number 1 is the most expensive private school in the district. And they're always number 1. But can you imagine that? From 1 to 52, you can find out every school in the district where they rank. Although I think in the US, we're doing that too, aren't we now, with these, where you can find out which are the failed schools and not the failed schools and all that nonsense. Anyway, so the thing that bothers me, a lot of things about that bothers me, but the thing that bothers me the most, if you like, is this Scholastic Olympics is not education. When the teacher tells a kid who's doing something, don't worry about that, it's not on the test. That's like putting the fingernails on the blackboard. I mean, it's just. So I went to the Maker Faire in New York. I've been there before, but it just reinforced the view that learning begins by making something. That was the point they made the educational track. They said, if you're going to teach a new concept in the school, put something in their hands and have them make something that gets you into. Don't have them read the chapter and answer the questions at the end. Okay? And so they call the way you make something the material, right? So they're saying is the computer is a versatile material that can be used to make projects. Well, what kind of projects? So what can I make with the Olpc laptop? Well, toys from trash. Let me go back and show you a specific example of that, which means I have to go back over here, I think. This is actually PHET. Let's do PHET first. These are simulations done at the University of Colorado. And one of Kishwar Aziz's teachers in Pakistan was saying that he had to teach the students how to make the area, or how to determine the area of an irregular polygon, right? So if you can imagine you're trying to determine the area in a parallelogram, that's not so obvious. Well, PHET has a way to do that, which is you can, I have to keep remember to drag. And as you put these squares representing 1 square unit, it'll show you the area and the perimeter. Right? Up here, perimeter is 8, area is 1, and you can, make it any kind of object you want. And so you can illustrate exactly how this works, and you can make arbitrary figures with this thing. And they have tons of these, but we don't have time, obviously. You're more than welcome to log in and take a look, of course. And it's on you can go to the PHET website and you can see, because that's all I've done. Nothing on the school server is there that doesn't really exist also on the internet. Okay, now I get back to here. Okay, then we were going to do toys from trash. Let's see if I can do that. How am I doing on time?
You're okay.
Okay, all right. No, I don't want to do that. I don't want to do that. That's the IRC thing. So if I go back to the school server, and just open it. And I go back over here, we can do, I don't really have the toys from trash here. These are the Arvind videos in Hindi. But what the toys from trash are is a very large website, I think 100 gigabytes, something like this. And each tab or each link that you click to gives you a scrollable set of slides. The first one shows you what are the ingredients you do to make this particular item, and then step by step how you make it. And one of the beauties of it is the pictures are sufficient. You don't need text to explain how to do it. So it doesn't matter about what language it's in, you can do it anywhere. And these items are made with, you know, the swizzle sticks that we stir our coffee with, paper, cardboard, rubber bands, soda straws, all kinds of things. So the one I was going to show you is a rain gauge. So all they did was they took maybe a liter or a liter and a half bottle of perhaps water. You cut it off below the curved part, you know, where the circumference is. You turn that part upside down, and of course you open the bottom, and you stick it out, and when it rains, the water goes in, it's funneled in to the bottle, and at the end of the day, you can go out there and you can measure what's the depth of the water. Trivial. But then, how much water's in the bottle? Well, now we have to know the circumference. We have to know the depth, right? Well, how do we know, say, how much rain there was per inch? Well, now we have to know what was the rain being captured, which is the circumference, right? So then you have to know if this much rain fell from this much circumference, then how much rain fall you had. So the point I'm trying to make here is almost all of these activities will lead you easily into really what they call authentic math issues, where the kids have to solve a math problem. Now, most of us are familiar with the standard word problem, which is Jill has 5 candies, Bill has 4 candies. When they put them together, how many candies do they have? What is this, right? That's not a real problem for the kids. So I really think this toys from trash, in Rwanda, they're requiring the schools at the secondary level to put in a science lab, which I can imagine will have a chemistry desk, retorts, beakers, Bunsen burners, you know, all this stuff, which is going to cost a huge amount of money. And what I'm looking for is where they can have authentic experiences in actually doing measurements and calculations in science that don't cost anything or as little as possible. And so this toys from trash for me is just absolutely marvelous, but PHET as well, because they're using a simulation. Okay, now let's see if we can get back over here. Okay, Lion. At the, I got it on the Sugar Labs oversight board. I think it was more by Adam's fault. So if anything came out, it's his fault. Anyway, one of the first issues came up is we needed a localization manager. Localization is L10N because that's the way they're doing it now. Internationalization is I18N, the number of letters, right? Well, the only thing I could come up with is Lion, because if I put L10N in as a sugar activity name, it won't work. There's something in the software that throws it away. So anyway, so I built this Lion activity because the point I tried to make to them is this is a fantastic learning opportunity for our students. Think about this. What you're doing is you're taking the text from sugar that's in English and you're providing a translation string in your native language. Okay, so if I go in the US and say, well, how many Yoruba fluent people can I find? Not many. But if I go where Yoruba is spoken as the native language, it's not hard to find them at all. In fact, the students know because they grew up in that language. So now what we're going to say is, why can't you translate from English to your native language? And by this, you'll learn a lot of English because you'll have to figure out what the English meaning is before you can figure out what the local meaning is. And you can break up with the issues of, do you translate computer into a new made-up word in the native language, or do you just use computer for the various words? In French, a computer is an ordinateur, right? Because the French, it's not going to be an English word no matter, right? We're not going to allow that. So every word, logiciel, is a program. I don't know what a programmer is, but it's probably somebody who does logiciels.
Starting to run out of time.
Okay, anyway, so lion is a sugar activity. Well, in order to get to a sugar activity, I have to, let me show you this. I've got on here the sugar on Ubuntu. So to get to it, I have to log out, which is okay. Because this will show you how you get to Ubuntu on machines other than XOs. And then you go down and you pick sugar as the one you want, and then you just log back in again. So it's very similar to the way on an XO that you get over to the GNOME desktop. And so now we have sugar. So this guy down here is the lion because he looks like a lion, I suppose. And what you do with this, the first thing you do is you pick out your target language. So it doesn't probably matter too much. Pick English, we've got too many of. Let's say Spanish. Yeah, why not? Okay, so you double click that. And now you have a list of the activities that are installed on the XO. Now, the Sugar Ubuntu has a different username for each user. So I'm Tony, not Olpc. So therefore, the bulk of the activities are installed in a common space, but the only one this activity can operate on are the ones that are installed in the local activities folder. But it doesn't matter because we'll pick shot as the example. Okay, and so what you get up here is a comment. You get the string that's in English in the source language, and you get the string in the target language. So this down here would be chat translated to Spanish. Now, let's say that we're talking about a language where the translation doesn't exist. Then what you're going to see is that. And what the student's going to do is type in, I just made a lowercase so it's different, and accept. And it'll show the next string. And you keep going through string by string. When you get to the end, it says you're done. And then it saves that file back in the activity. Then if you switch the locale, which you have to do anyway, switch the locale, let's say to Spanish, and then you open up that activity chat, you're going to see your strings, not the original English strings, right? So this means a student can sit there, pick an activity in 20 minutes, translate that activity from English to their native language, store it on their XO, open it up again and look at it. And among the whole class, they can finally decide, well, I think your translation is better for this string, or, they can argue about it, discuss it how they want to. But at the end of the day, they can have an activity localized right there without having to deal with anybody anywhere.
We're going to start.
Okay, yeah, let me get, I can at least, I think, no, that's right, I can't get back to the presentation on this side. Temporary glitch. So anyway, to get back, it's just like, no, you go back to my settings. I'm sorry, you don't. You go back to logout, and you log out on this side. And then you go back and change this thing back to Ubuntu and log in again. And I'm going to go back to the presentation, which I probably have to start all over again. Let's see. I think I'll do it this way. A second here. Olpc. There we go. Okay, we were down here with the make business. So what else can you do? I can't show it to you because it's running out of time, but in the explore part, and I have to show you this one, but I can't. Oh, dang it. This is horrible. Anyway, a Google Summer of Code student 2 years ago created a fiddle capability for browse. If any of you are familiar with the web, you can go to this JS Fiddle and you can put in HTML or you can put in JavaScript and you can click on it and it'll show you what that page would look like or what that JavaScript script would show up. Well, she created this exact same capability for browse. But she didn't have time because this is typical of the GSOC projects. They get about 80% done and then it's over. And so we hardly ever get anything useful out of it because the last 20% doesn't get done. But this year, Utkarsh Tiwari, who was a GSOC participant this year, finished the job. And so now we have a version of Browse that has this capability. What this lets you do is you can, for example, save a web page in the journal. You can load the web page into Browse from the journal. You can install an image in that web page. You can show the source code of that web page, which Browse currently doesn't do. There's a lot of things that were nice things to have, but the main one is this fiddle where you can type in HTML, CSS, and JavaScript, and then you can run that page and it'll show you what the browser does with that content. You can save it, but when it saves it a full web page, not just the fragments, an executable web page. So you then could go with the URL using file : / to that URL, and you could show that page locally. So this means the kids very quickly can do web pages. They can do JavaScript, all these good things directly.
You got 10 minutes.
Oh, before your part.
10 minutes to wrap up everything.
Okay, and you have things you need to say. Okay, so anyway, the statement was made yesterday, which I found totally outrageous, that you could not do development on an XO. One of the really gorgeous, beautiful features of Sugar is you only need Sugar to do any development you want. It's all in Python. You can go to the terminal activity. From the terminal activity, you can destroy the system because you don't have an admin password. And the developers say, oh, these students, we better do something because these students could make a brick out of their XO. Of course they can. If you want them to make something, they have to be able to break it. If you go to a maker faire, the first thing they say is, project's not successful until you break something, right? And so what happens if they break the operating system? You flash it in again. No problem, right? They can't possibly break the hardware. So anyway, you can do Sugar activities. There was some discussion about, well, even in that presentation, at the end of the day, they couldn't get their font editor made into a Sugar activity. Crazy. They should have started with a Sugar activity like Hello World and built there on top of that, because then they will always have a working Sugar activity. But most of our developers don't have an XO. This is a big problem with GSOC, is that these participants from India, they don't have an XO. They don't have any idea. Okay, booklets. You can make a booklet, 8-page booklet, take an 8.5 by 10 sheet of paper, or in Europe it's A4, and you print 8 pages, 4 on each side, fold it twice, cut it in half, staple them together, and you can have an 8-page booklet, right? These are things I think kids should be doing with the XO. And my argument is, have the 4th and 5th graders do it for the 1st and 2nd graders, because they have the right vocabulary. They know what the kids are interested in. They'll do something the kids like, make it mostly pictures and very little text, and let the kids read it. As I say, you have access to Sugar. You can do anything with it. Okay, so Desiderata. One of the questions I try to ask is, at this deployment, how much time per week do the learners have access to the computer? Well, in Rwanda, the only way the kids get access to the computer is because the teacher drags them out of the storage area, sets them up in the classroom, and sets up time for them to use it, and the whole period length is 40 minutes. So by the time they actually get the thing booted up and running and do something, it's probably less than 20 minutes, and then it's shut down. And all of you went through school, so all of you know that you never got to finish anything. This teacher said, time's up, close your book, turn the paper over, you're done. That's one of the most frustrating things for me about school is you don't get to, you get started on something and then you're stuck because the time ran out, the bell rang. Well, and how much of this time is available for the student to work on a project of their own choice? In Rwanda, 0. Teachers control every minute of access to the computer. But we had an interesting data point when the Endless talk, which is that the average American spends 4 hours a day on their PC. Is that too much? Is that not enough? Is it about right? How many kids with Olpc laptops are getting 4 hours a day usage of that laptop? Not many. But if you're going to do a project to build a program, for example, like programming, I don't know any programmer who can program in 15-minute spurts once a day, right? Or once every other day or something. Okay, then this is some things that came out of this Maker Faire. How do you decide in a classroom environment what projects the students should work on? They said, okay, what we do is we have project possibilities written down on sticker papers and we put them up on the wall. And then we have the students go up and sign up to a sheet of the project they would like to work on. Nobody signs up, we don't do that project. The ones that sign up, they make the group to do that project. If somebody wants to do a project, nobody else signed up, they do it by themselves, right?
We got
Seems like a good way.
5 minutes left.
Okay,
Exactly.
I'm almost done. And, but this is one the teachers, I think, will understand. Don't use rubrics. Why? Because the kids will do their project to meet all of the checkpoints in the rubric. So if you do a rubric, you're going to constrain what they're going to develop. So don't do it. And as a mentor, if a kid says, hey, I don't know how to do this, we're stuck, you don't go over there and unstuck them. You don't go over there and tell them, do this and do this. You just say, have you tried this? You know, have you looked up on Wikipedia to see how this might work? So you give them some guidance that might get them a way around it, but you can encourage them that they're going to have to solve their own problem. And then finally, at the end of the day, how do you assess the whole thing? You'd have them take the output and put it in a portfolio, and then you evaluate that object for its own merit. Right? Okay, anyway, now that I've taken all your time, and a Q&A probably.
So I'll just ask one question as we turn this into a Q&A. How do we unleash teachers? Okay, there's a claim that we're unleashing kids. So I have two ideas on how to unleash teachers. One comes from my father, who had great success in the 1980s with teachers in Canada distributing their curriculum between all these computer labs around Canada. And so they had an open source Xerox-based photocopy machines to move around their lesson plans. So the idea is support that proven gossip between the teachers using $100 school servers. And number two, make it easier to move around these content packs and lesson plans, many of which Tony described admirably. But if the teachers can never find those or get them, it's not going to happen. So that's just my leading questions as we turn this into a Q&A. There's a lot of us working on those two problems. Take these proven servers that are $300 to $500 and put them in the hands and actually put them into purses. We have one we nickname Internet in a Purse. So if we can pull all the bureaucracy out of the way of these leading teachers, will that create lots of ecosystems underground, above ground, everywhere, so that teachers can create alongside, not to threaten the Ministry of Education, but alongside and education innovation can bubble up from the bottom, side to side. So that's my leading question. We don't have to talk about that. Let's ask Tony anything you guys want to ask.
Throwing rocks is permitted. Okay, if you get a chance, try to log into the machines and see what's there, particularly the Rachel machine, but you can get into the Nuke, that's the IIAB. We unfortunately don't, well, yes, we do. We have, but Alex's machine is also a Rachel. Rachel gives, you can buy from Rachel. This Rachel Plus is $399, and the Raspberry Pi is what, about 70 or?
Well, the hardware is 70, what's on there.
Yeah. So
And then what I put together had sort of a special purpose, which may or may not be necessary.
But if you go to the Rachel, it's World Possible or World's Possible Rachel website. They have on their sheet what they sell. There's the $399 one we have back there. And the question I would ask is it worth time for me, for example, to spend my time supporting school servers that I just use Rachel? If it's going to cost $384 to put together a nuke and then put on all of this content and so forth, is that extra value worth it aside from just buying a Rachel and putting that in the school? I guess that's a question.
Well, what would you put on your server that isn't on the Rachel? Isn't that the question?
All the stuff you just showed.
Well, then of course the question is, what can I add to the Rachel server? They claim that it's possible to add additional content to it.
Yeah.
And they claim it's a terabyte, as I recollect. Maybe it was only 500 gigabyte. I have to go back and look at that. Yeah. Well,
That's still
right
a
now
lot.
our content is 500 gigabyte. Now, if you want to have space for kids to back up their journal, Olpc estimated 2 gigabytes per student is what should be allowed for the backup of the journal. Then you're talking about well over 500 gigabytes of space you need. But the cost of hard drives is so cheap. A terabyte hard drive, $78. If that's not enough, I think I can get 2 terabytes for probably $120. Yeah. Now, the other thing is, it's not an internet in a purse, okay? It's an internet in a school. So the school may have 400 laptops, but they only have one school server, right? I've not yet had a school where we've had to have more than one school server. So that cost, of course, if you look at the business point of view, that cost becomes basically negligible when you're talking about a $20,000 project.
So we're not working just in schools anymore. We're working in medical clinics, and so
Yeah,
there's a change. There's a change happening.
yeah. I haven't figured out how to do schools yet, so I'm not ready to take on anything else at this point. The only one I've been involved with is Cliptown Youth Center in Soweto. And there Google came in and gave them a complete computer lab with the most modern desktops and the biggest monitors and the biggest keyboards. So I don't think they're using their old PCs much anymore. We kind of got drowned out.
So we need an app store for these free content packs. And Rachel's made some good headway there. And the talk yesterday that Endless hinted at where we need to go to have offline, online content dancing with one another. And maybe we're biased in favor of app stores. Maybe a lateral network between teachers can take root in some countries.
Isn't Aslo our app store?
Possibly. You can't at the moment, move
What
around
can you do?
10, 100 gigabyte, chunks of OpenStreetMap. It's not really designed for that at the moment.
No, that you do by burning, because you can't, again, yeah, if you have 4 megabyte per second internet access, yeah, you could conceivably download this stuff, but
So it's as much
in the field, that's not going to happen. So
it's as much of a ratings agency like Yelp as it is an app store. So the teacher's time isn't wasted. So they can find out what other teachers in their part of the world, like all these.
What is that? What is it? Is
Yeah,
that a website or?
No, it's where all these offline, all these offline referral things have to go. Whether it's Endless, Rachel. If you look at dev.worldpossible.org, it has the outline of the quality of each content pack. At the moment, that's a number from 0 to 5 that's arbitrarily chosen, but it's still incredibly useful, right? And we need to develop that. And yes, likes and dislikes are a part of that. And how do you tabulate those regionally, et cetera?
are they getting those back from the field, or are they getting those back from the internet?
Anecdotally, from everywhere at the moment.
Okay. So I don't know how you rate, it's useful or it's not. If you're searching Wikipedia, how do you say this article is more valuable than that article? Depends on what you're interested in. So with a hard drive, a big hard drive, you put everything you can possibly put on there, and some of it may turn out to be useful, and some of it may never be used.
So yeah, the
And
breakthrough.
also then adding different languages, these kind of things.
Right. Now, that's an area I didn't mention, but that's tricky. With Keywix, we now can put any Wikipedia, Wiktionary, any wiki, anything on a school server. And it's a standard format called Zim. And with the Zim format, you can put it on the school server. So now it becomes really important. And so each deployment needs to say, yes, my base language and this is French or it's Spanish or it's English. But in addition, I want to get any content that might be available in the local language that is there. We have the capability to do that. Now we need to figure out how to create the content in these languages that are not so widely used, which again feeds back into this Dominican Republic where they want to save the languages. We have wasted, to my point of view, an opportunity here. The XO out in the field could have been used by having the kids go out and have their grandmothers record the stories, record the songs, okay? And we could have that record at a world level today. But I don't know anybody who's encouraging that or getting these kids out there to do that.
We did that in India and we ran out of money and supported, we recorded stories in the village of grandparents. We also got the children in Pondicherry, in one of the schools to photograph the flora, fauna, find out stories about it, sort of map the locality, and that's a small idea.
So where did the cost come in? What was the
We had zero help from Olpc for anything, whether it's to buy laptops or to support.
So you didn't have the machines to let the
We
kids do
we
this?
had the initial round of machines and that's it.
And
I mean, that's a whole.
the only
separate
additional
story.
cost I would see is figuring out how to go to the
We
internet cafe and upload.
we didn't even have enough fund for the volunteers to cover their transport and all that. We kept it going for 4 years till everyone ran out of money.
Yeah, but I think that the kids didn't have any trouble doing this, right?
Not at all. I mean, what you
Yeah,
say
so-
is true. I mean, everything is there, it's sitting there, but unlike Nicaragua, who've done a wonderful job, we haven't.
Yeah.
I think we know all the theory and we know everything, what needs to be done and can be done, but for various reasons, we've not been able to do it.
Money always ends up being the barrier, I guess. But giving them a computer that has a microphone and a camera, including the ability to take video,
Right?
is marvelous. And hopefully with this newer computers, we'll actually have the ability to do video editing and some of the things that we can't do now on the XOs. That would be part of that.
Well, we have 2 sustainability speakers coming up in, 10 or 15 minutes, so maybe we should break.
Yep. I need to go get something.
All right, more questions? Go ahead.
Well, I just have a question, which I guess I've raised with you and I still don't understand the answer. And that is, if the Rachel can have this still version of the things that we now look for on Wikipedia or look for on a Google search, then why would not the people who make these laptops and make these phones that sell for $700 and sometimes for $1,500 say, okay, would you like to have an additional chip in your phone that will give you access to all of Wikipedia or at least a still version of Wikipedia, maps, Google books, all these other things. Why is that not happening?
Well, if you're willing to fund that company, maybe you can help us answer that question. The oversimplified answer, which is a little bit slanderous, is that the smartphones are often subsidized by the carriers whose incentive is to sell you more bandwidth. So they do not, in many cases, this is kind of harsh, but they do not want that content on the cell phones because it hurts their business model. Now, that's kind of harsh, but it's also true. So if you're able to work with certain smartphone companies or whatever device companies to do that and not threaten the established carriers, then go to it. And that's a little bit what Endless is doing, right?
Yeah.
It's Endless as a company is doing almost exactly that, saying how do we create such a company without threatening the telcos?
But at the end of the day, it's the amount of storage capacity. And for this, the school server is a good answer because we've been very fortunate. The cost of computing power is going down every year, and the cost of hard drives is going down phenomenally every year. So the ability to be able to have an inexpensive machine that can deliver a large amount of content is there. And in a school environment, you have a lot of users that are near enough that they can take access to it. To use a school server in your home, probably not as attractive. But if you've got 400 laptops serviced by the school server, it becomes I think very attractive approach.
So I just want to thank Adam and Tony.
Gotta have that guy, 'cause he doesn't know about it.